At the end of this module, we'll be able to understand about the operation on matrices such as addition and subtraction. Such operations are quite common to the normal multiplication and addition of two numbers.
There are several operations related to matrices, like their addition, multiplication, etc. Addition of matrices. If A is equal to Aij and B is equal to Bij are the two matrices of the same order, then their sum, A plus B, is a matrix whose ijth element is Aij plus Bij. Example, add and subtract the given matrices A and B. Solution. We can add A and B by adding each and every term of matrix A with a term at the same place in matrix B, like 2 plus 1, 0 plus 1, 1 plus 1, and so on, which gives us A plus B. Similarly, we can subtract these matrices, which gives us A minus B. Multiplication of a matrix by a scalar. If we multiply a matrix A with a scalar quantity, then each and every term of the matrix gets multiplied with that scalar number. That is, if A equal to Aij with order m by n is a matrix and K is a scalar, then Ka is equal to Kaij with order m by n. Example, if A is a given matrix multiplied by a scalar 2, then its each term gets multiplied by 2. Properties of addition of matrices. If the order of the matrices A, B and C is same, then A plus B equal to B plus A is a commutativity. A plus B plus C equal to A plus B plus C is associativity. If M and N are scalars, then M times A plus B equal to M times A plus MB. M plus N times A equal to MA plus N times A. Multiplying matrices. Two matrices A and B can be multiplied together if the number of columns of matrix A is equal to the number of rows of matrix B. They should follow the given condition. Matrix M with order m by n into matrix M with order n by p gives matrix M with order m by p. Example, multiply matrix A with matrix B. Solution. First multiply row on A with first column of B, which gives first row of new matrix. Repeating this procedure, we get A times B matrix. Properties of matrix multiplication. Commutative law does not hold in matrices, whereas the associative and distributive laws hold good for matrix multiplication. In general, A into B is not equal to B into A. Matrix multiplication is associative. A into B into C is equal to A into B into C. Distributive laws. A into B plus C is equal to A into B plus A into C, or A plus B into C is equal to AC plus BC. Example, find x for the given condition. Solution. Multiplying first two matrices and then remaining two matrices. Putting it all equal to 0, we can solve for x and get x equal to minus 1.
So, in this video, we'll be learning about transpose of a matrix and symmetric and skew symmetric matrices. These properties of a matrix are very important for us to understand.
A matrix obtained by changing rows into columns or columns into rows is called transpose of the matrix, say A. If the matrix is A, then its transpose is denoted as A with subscript T or A dash. For example, consider the matrix A, B, C, D. Changing rows into columns, that is, the row AB now becomes a column and the column AC now becomes a row. The transpose of the above matrix is ACBD. Properties of transpose of matrices. First, if A is a matrix, then double transpose of A is equal to A itself. Second, A plus B whole transpose is equal to A transpose plus B transpose. Third, K times B whole transport is equal to KB transpose, where K is any constant. Example, if AB matrices are given, then verify that A plus B whole transpose is equal to A transpose plus B transpose. Solution. First, find A plus B. Therefore, A plus B whole transpose will be 7, 9, 0, 11. Now calculate A transpose and B transpose individually and add them. Compare the values of A plus B whole transpose and A transpose plus B transpose. Hence, it is true and verified. These are equal. A square matrix A is called a symmetric matrix if A transpose is equal to A. For example, the given matrix is symmetric in nature. Skew symmetric or asymmetric matrix. A square matrix A is called a skew symmetric matrix if A transpose minus A. For example, the given matrix is skew symmetric in nature. Note, any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix, that is, a matrix is equal to symmetric plus skew symmetric. Example, show that a matrix A is a skew symmetric matrix. Solution. Let us find A transpose first. Take out negative sign common from the whole matrix. Now we can see that after taking out negative sign out, we get matrix A. So A transpose is equal to minus A. Thus it is shown that the given matrix A is skew symmetric matrix.